Lesson 7, which is solving quadratics by any method. So throughout this unit, we've learned different ways to solve a quadratic. First, we learned how to solve by square roots, then factoring, and finally, when all else fails, you have the quadratic formula. Remember that these first two methods are much faster and easier to use, but they have limitations as they don't always work, depends on the problem. Where the quadratic formula takes a little bit longer to use, but it always works. I've made a little flowchart to help you decide which method you should use to solve a given quadratic. When you first see a given quadratic, you should ask yourself whether or not there's a linear x term, which we see as bx. In a problem like x squared minus 5 equals 0, we have an x squared term, a constant term, and no x term. So in that case, the answer would be no. Where a problem like x squared minus 5x plus 4 has an x term, so the answer would be yes. If you've decided that you do not have an x term, then you're going to solve it using square roots. If there is an x term, the next question to ask yourself is there a number in front of the x squared? In a problem like 5x squared plus 3x plus 2 equals 0, there is a coefficient in front of x squared, so the answer would be yes. In that case, we're going to solve by the quadratic formula. If there's not a number in front of x, which means that there's a 1 there, then we're going to try to solve by factoring. We've been pretty nice to you throughout this unit, where most problems where the leading coefficient is 1, we've made them factorable. But if you were to try to factor and it didn't work out, you couldn't find any two numbers that worked, then you could always still use the quadratic formula. So when you see a problem that says solve by any method, this chart would be a really good guide for you to decide which method to use. So let's get into some problems. With this first problem, I have an x term. That means I'm either going to be using the quadratic formula or factoring. My leading coefficient is 1, meaning there's not a number in front of x squared, so I'm going to try to factor. Remember, that means making a t-chart to what multiplies to the constant, 3, and adds to the x term, 4. Well, the two numbers I come up with are 3 and 1. They multiply to 3 and they add to 4. That means I can factor this original polynomial into x plus 3 and x plus 1. And now I'll solve each of the factors. I'll set x plus 3 equal to 0, and I'll set x plus 1 equal to 0. That gives me x is negative 3 and x equals negative 1 as my two solutions to this quadratic. And this problem is done. Now in number 2, I have an x squared and constant term, but I do not have an x term. That means we're solving by square roots. So I'm going to move this 9 to the other side and get x squared equals 9. Then I'm going to square root both sides, remembering that when I square root, I need to have the plus or minus. So I'm going to have x equals plus or minus 3, as the square root of 9 is 3. And that really represents two solutions, 3 and negative 3, which are the two solutions to this quadratic. All right, on to number 3. This problem has an x term. We see that right away. That means we're either using quadratic formula or factoring. Now, something to think about with quadratic formula and factoring is that they always equal 0. You always start with standard form equal to 0. Well, in this problem right here, I am not equal to 0, I'm equal to 8. I need to fix that. I'm going to do that by subtracting 8 from both sides. That's going to let that right side equal 0, and my left side will be 3x squared plus 5x minus 8. Now I'm going to take a look at my leading coefficient. It's not 1. There is a number in front of x squared. So if there's a number in front of x squared, we want to solve it by quadratic formula. So I'm going to label my a, b, and c and write out my quadratic formula. Next, I'll plug these values into the formula, and now I'm ready to start simplifying. I'll rewrite it and clean it up a little bit. I'm going to turn that 5 squared into a 25, and I'm going to save that mess for later, and then the bottom can clean up to 6. Now I can deal with the mess on the inside. Because we have two negatives here, that's going to make a positive, so we're going to put plus. And then 4, 3, and 8 multiplied together will give you 96. Next, we can simplify here inside the radical and call that 121. So we have negative 5 plus or minus the square root of 121 over 6. And conveniently, that's a nice perfect square, which we can square root to 11. And I've kind of run out of room with this plus or minus, so it's time to split it up. So I take negative 5 plus 11 over 6, and then negative 5 minus 11 divided by 6. This becomes 6 over 6, or x equals 1, and this becomes negative 16 over 6, negative 2.67 according to my calculator. So now I have my two solutions to this quadratic. Now this last problem is a tricky one because it's not actually covered by our flowchart. You could solve this, and I think the flowchart would tell us that because that leading coefficient's not 1, and because there's an x term, that we should use quadratic formula. But let's not forget that other version of factoring that we learned earlier in the unit called factoring out the GCF. When you only have two terms, and it's not a square rooting problem because you have that x term, it's a factor out the GCF problem. So I start by figuring out what the GCF is, and I'll start with the numbers of 8 and 24. And since 8 goes into 24, that makes 8 the GCF. And now they both have at least one x. The smaller power here is x to the first. So 8x is the true GCF. And now we're going to set up our parentheses and look at how we can rebuild this 8x squared plus 24x. We have to ask ourselves what times 8x is going to give us that 8x squared, and that would be x. And then what times 8x is going to give us this 24x, which would be a positive 3. So now we factored out the GCF, and we have 8x times x plus 3. Now we'll split up the factors using the zero product property and solve each for when it's equal to 0. So when does 8x equal 0? Well, if we divide by 8, we get x equals 0 as our first solution. And when does x plus 3 equal 0? Well, we subtract 3 from both sides and get x equals negative 3 as our second solution. So x equals 0 and x equals negative 3 are our two solutions to this quadratic. So in this lesson, we put together the three methods of solving a quadratic that we've learned throughout this unit. The first was solving by square roots. The second was factoring, which don't forget includes factoring out the GCF. And the third was the quadratic formula. While the quadratic formula always works, it's important to understand all three of these methods so that you're making the most efficient solving choices you can. I would take time to familiarize myself with that flowchart and practice, practice, practice. If you came away with anything else, write that down now. Otherwise, we'll see you in the next unit.